All right, let's start that over again. All right, we're going to talk about a specific type of parallelogram, and the first one today, we're just going to spend today talking about this particular type of parallelogram. Now, you guys said it was a rectangle, but you can't say it's a rectangle just yet. Looks like one, but just because it looks like one doesn't always mean it is one. What do you think you're going to have in here to be able to say that it's a rectangle? No, not even sides, because a parallelogram that's slanted, right angles, that's right. Okay, and that's the definition. The definition of a rectangle is this. It's a parallelogram with all four right angles. Do you hear me? So they start off saying the rectangle is a parallelogram. So if it's a parallelogram, then the opposite sides are equal, right? The opposite sides are parallel. The opposite angles are equal. The consecutive angles are supplementary. We forgot to mention that yesterday, but that's true. What else? The diagonals bisect each other, right? So all the stuff that's true about a parallelogram is also true about a rectangle. But there's one more thing that's true about a rectangle that's not necessarily true about all the other parallelograms, and that would be that all four angles are right angles. Okay? So if you have a parallelogram with all four right angles, that means you have a rectangle. Okay? And again, what does that mean about this rectangle? Well, they're all four right angles. The opposite angles are equal, aren't they? Because they're all 90, right? So the opposite angles are the same. The opposite, or the consecutive angles, the one right next to each other. Okay, on a parallelogram, what's true about the consecutive angles? They're not necessarily equal to each other. They're what? They're supplementary. Are they supplementary here? Sure they are. Okay, because 90 and 90 is 180. So they're supplementary. So that's true. The opposite sides, right? Since you've been a little kid, a rectangle basically is four sides with the opposite sides being equal to each other, right? Remember that? Yeah, you probably knew that. I'd probably go down to the elementary school and they could probably tell me that part of it. Okay, but they probably don't know about the diagonals. They don't know about the parallel sides. They don't know all about that stuff. So the opposite sides are equal to each other. The opposite sides are parallel to each other. Agreed? Because it's a parallelogram. The opposite angles are equal. The consecutive angles are supplementary. And what's true about the diagonals? They bisect each other, right? Because it's a parallelogram, they bisect each other. Now, here's another thing that's special about a parallelogram. I'll tell you what, let's list the two things that are special about a rectangle, I should say. Okay, all the angles are right angles. Okay, so that's one thing that we know about a rectangle. Here's a second thing that we know about a rectangle that's not necessarily true about all the other parallelograms. Okay, this is only true about a rectangle. All right, not on all the other ones, just a rectangle. Look at the diagonals. Now we know they bisect each other, but if I was to do this, now might be a good time to pull out the ruler. Did I show you my ruler yesterday?
No.
I didn't? That is a big ruler. Okay, let's... Oh, okay, that's why it's doing that. Okay. Now let's see if I can do this. I'm going to try to measure it. This is the first time I've done this. I have to rotate it a little bit more. About too much. Too much. Maybe this is why I haven't done it before. That's close enough. We'll get a ballpark estimation of it. Okay, so, oops, what did I just do? Alright, so let's put it about right there. That's pretty close. So it's, I don't know, a little less than 13. Would you agree with that? Alright, now I gotta do that whole thing over again. So now let's try this. Let's try spinning it around like that. And let's see. We'll get that about, spin it around just a little bit more. Maybe not so much. That's pretty close. And sure enough, look. That's pretty close to about the same, isn't it? Not exactly, but you get it. You get the idea. Okay, so what's true about these diagonals here? Let's get that out of the way. Maybe get it out of the way. There we go. Get out of there. Okay, good. What's true about the diagonals? What did I just show? Took me way too long. They're equal to each other, right? So let's write that down. So the diagonals are equal or congruent, whatever you want to say. So if they're congruent to each other, now watch. Remember, because it's a parallelogram, they bisect each other, don't they? Right? So if this diagonal and this diagonal are equal to each other and they're both being bisected, guess what's true about all these segments right here? That this one is equal to what? This one, which is equal to this, which is equal to this. You see that? So all these from here to here, from the middle to over this corner, the middle of this corner, middle to this corner, all those segments are all equal to each other. Why? Because the diagonals are equal to each other and they're both being bisected. So that must mean two equal things, both split in half, all those segments must be equal to each other. Would you agree with that? All right. So those are the two special things that are true about a rectangle that are not true about the just a normal everyday parallelogram. Ben?
Does it matter if you put one mark on the outside?
Well, I probably shouldn't have done that, right, because these have one mark. I just did it to just to show that they're equal. You're right. Technically, I probably should have done this. Is that better? Okay, there we go. So yeah, technically I should have done that because that doesn't mean that this and this are equal to each other. Absolutely. All right. We okay with that? Pretty easy, isn't it? Yep. There's not much to it. Okay, but remember this. Remember that the diagonals are equal to each other because that's pretty important on what we're going to do. Travis?
So all the characteristics for a rectangle work the same way for a square.
Almost. We'll get to a square in another lesson. Okay. What do you think? What do you think might be? Let's just sneak preview here a little bit. What do you think is true about a square that may be different than a rectangle? All the sides are equal. That's right. So basically, a square. Now I'm giving away all the fun now because now you won't have anything to look forward to. But I'm just kidding. You're taking me so seriously this early in the morning. All right. So anyway, look. A rectangle right here, the opposite sides are equal. So it means that this side and this side are equal to each other, but not necessarily equal to these two sides, right? On a square, though, all four sides are equal, and all the other stuff is true. And there's something else that's special about it, too, and I don't want to ruin all the fun, so we'll wait till we get to it, okay, when we do the next lesson. I think it's tomorrow. Let me see. Yep. We're going to do a rhombus and a square tomorrow. You ever hear of a rhombus? Okay, we'll do that tomorrow. But you can't wait. All right, let's see. Is there anything else about a rectangle? Oh, there's one more thing. Remember yesterday? Remember we said if it's a parallelogram, then all that stuff is equal to each other, right? Well, if it's a rectangle, then all the angles are right angles, right? The diagonals are equal to each other. So what do you think we can do now? We can say, now let's say I don't know that's a rectangle, but I do know that that's a right angle and that's a right angle. That is and that is. Okay. What if I know it's a four-sided figure? I don't know it's a parallelogram. I know that it's a four-sided figure with all four right angles. So if it's a quadrilateral with all four right angles, then what do you think I can say about this thing? Then it's a what?
Rectangle.
No?
Parallelogram.
Well, yeah, you could say rectangle, but you could say it's a parallelogram. Would you agree? And you're right. You could say it's a rectangle as well. Okay, so if I have a quadrilateral, just four sides, but what do I know about it? I don't know any of the lengths of the sides. I don't know that the sides are parallel. I don't know any of that kind of stuff. The only thing I know is I have four sides with four right angles. What do I know about this thing then? I know that then it's a rectangle. So if you have a quadrilateral with four right angles, so if you have four right angles, then it's a what? It's a rectangle. Okay, and if it's a rectangle, of course, it's a what? It's a parallelogram. So look, this is the only thing I know. If that's the only thing I know, what else could I say about it? I could say that the opposite sides are equal. I could say the, what else? We already know that the opposite angles are equal and the opposite angle, or the consecutive angles are supplementary. What else could I say? Oh, I could say that the opposite sides are parallel to each other, right? We're just saying the same stuff that we said earlier. What else? You could say the diagonals are equal to each other, and the diagonals, what else? Bisect each other, right? So there's a lot of stuff that we can say just because we knew that the four angles were right angles. Make sense? Okay. All right, let me just take a quick peek here and see if there's anything else I need to cover. I think I hit everything. let's do a quick example here. Do you mind? Okay, good. Glad. Alright, so we've got this. Now they tell you right off the bat that this is a rectangle. And they put some diagonals in here. So they put one right there. They put one right there. Okay, and let's label this thing. This is right in the book. It's on page 420. That's J, that's P, that's K, M, and L. Alright, so we've labeled it, and here's what they tell you. They say that this thing, that JKLM, is a rectangle. So if it's a rectangle, we know a bunch of stuff about it. We know you got 4 right angles, you know the diagonals are equal to each other, you know the diagonals bisect each other, you know the opposite sides are equal, okay? All that kind of good stuff, alright? So here's what they tell you though. They tell you that angle KJL, where's that? KJL, that's this one right here. They said that that angle right there is, I'll put a little arrow there, is 2x plus 4 degrees, alright? And JLK, let's see, JLK, that would be this one down here. I'll put 2 arcs there. This angle right here is 7x plus 5. And they ask you to solve for x. It's really not that hard, I don't think. Now look, some of you guys still are a little bit shaky on this kind of stuff. I see sometimes on quizzes and tests that automatically, some people just automatically just set stuff equal to each other no matter what. They don't even look at it to see if they really are equal to each other, but they're not always. Now that might be a good guess, right? Because a lot of times that's true, isn't it? When I give you a couple things with x in it, a lot of times you do set them equal and you solve for x. But in this situation, are you going to set these two equal to each other in this situation? No. What do? What's the relationship between this angle and this angle? Did these two add up to 180?
They add up to 90.
They add up to 90. That's right. Where'd you get 90 from? Well, look. You know it's a rectangle, so you know that's a right angle, don't you? So look at this triangle. Look at JKL, that triangle right there. That's a right angle. So 180 minus 90 is what? 90. So these two must add up to 90. Do you remember that theorem we had a way back? When you have a right triangle, the other two angles are complementary to each other, which means the other two angles always add up to 90. Why? Well, because that's 90 already, right? Take 90 away from 180.
Aren't they consecutive interior angles?
Consecutive interior angles? No, that would be... no, they would not be. Because consecutive interior angles are with parallel lines, and they would be supplementary. So these are complementary, though. Okay, so anyway, you got a right triangle. This is 90. These two angles right here add up to 90. So that's all you do. You just add them up and set them equal to 90. Does that make sense to you? Do you see how we got that 90 right there? Because we knew it was a rectangle, so we knew we had right angles here. And so you look at this one triangle. How did I even know to look at that triangle? Well, look, this angle, right, connects this side to this side right here, connects the other side to the same diagonal side. So I formed a nice right triangle right here. You just kind of have to see that. You got to block out all the other junk. And now you just solve for this. What do you get? 9x plus 9. So if I subtract 9, that's what? 81. Divide by 9, and x is 9. There you go. If I wanted to, I could find out what both of these angles are, couldn't I? Let's just do that for fun. Do you mind? So let's do that. Let's find what this angle right here is equal to. So that's 18 and 4. That's 22, right? Degrees. You could just do what to find this? You could just take this away from what? From 90, right? You could just go 90 minus 22. Okay, or you could put the 9 in for this, and you get the same answer. So what's 7 times 9? 63 plus 5 is 68 degrees. Isn't that the same thing if I go 90 minus 22? Yes, it is. All right, you with me on that? All right, I think that's it. I think we're good. You want some problems to do, don't you? I don't want to disappoint you. No, look, I don't give you these problems just as busy work. It's just because that's what math teachers are supposed to do. Why do you think I give you problems like this to do? So you can do what? No, seriously, just don't say any sarcastic remark. Just give me a serious answer. So what? So yeah, so you can understand it, exactly. I mean, I think I did an okay job of explaining this, but I don't expect you to remember all this just by sitting there and watching me do all this stuff, and even you taking notes. All right? The only way that you're going to learn how to do this stuff is by doing problems yourself. All right, so that's why I give you these to do, not because I'm mean, grumpy math teacher. And I may be mean and grumpy, but that's not why I give you the homework, though. All right, there you go. So 10 and 19 and 26 to 32. All right, section 6.4. Make sure that you write section 6.4 on there and all this stuff and your name and all that good stuff. I think this is pretty easy. This is one of my favorite chapters, mainly because I think it's easy to teach, it's easy to understand, and I think it's easy for you to do. And I think most people have success on this chapter. You just got to keep up with the stuff. There's a lot of information. It's not difficult information. It's just a lot of information. So make sure you take good notes on this. Check the YouTube once in a while, right? You're sitting there in between commercial break of the football game. Go to YouTube. Watch a few minutes just to kind of refresh your memory and so you know what's going on in here. All right. Okay, that's it for today. Let's go over the homework that you had last night.